All right, welcome to Locality Podcast. We are just chatting here. I got Mr. Mac Hansen. Mac, how are you?
Good. How are you?
I'm doing really well. One of the things that has been really interesting about this time of year is we have a transition from winter to summer, and I don't think we really had a winter at all.
No, nope, we did not.
How has that been affecting kind of our Utah clients with their systems? Like, what have you guys been seeing out in the field? How has this very mild winter affected them?
Well, definitely not having as many units breaking down because they're not running as hard or as often. Especially, it's usually we're seeing a lot more of the breakdowns and issues coming in overnight because that's when temperatures drop. But during the day, as it warms up, they just kind of dissipate.
Yeah, I know that with a lot of the systems that are out there, gosh, it's kind of like miles per gallon that fuel efficiency is, but really there's a certain number of miles on a system before they start breaking down. And I heard a stat a while back. I don't know how true it is, so I'll probably need some people in the chat to help fact check this. But apparently, a 20-year-old system, it runs on average kind of through the probably more in the northern United States. If you were to take the number of hours that it runs when it's heating and you equated that to how long a car drives,
Hmm.
that a 20-year-old furnace has about as many miles, if you will, or use as a car that had 2 million miles on it.
Yeah.
And I thought that was really interesting. What's your reaction to that?
I've heard that in the past, but it kind of it it blows my mind that because there's not too many vehicles out there with 2 million miles on them. But these this equipment, they just keep going and going. It's always I heard it explained to me that helps me make more sense of it is the
Hmm.
cycle rates. So the standard on furnaces, they cycle about 3 to 5 times per hour. That's
Hmm.
how many times that furnace will kick on, run in heat, and heat the home, shut down, and cool down. So with our climate here, I think our average heating season is about 2,500 hours.
Hmm.
Um, it's a lot. I mean, you could have a furnace that's cycled on 7,500 times in one winter, and then you have equipment out there that's 20 years old, 18 years old. It's just a lot of cycles. But puts it in perspective for me is each cycle that's starting your car, driving it to the store, it's warming up, cooling down, starting it, driving it home, all that wear and tear on all those components.
Interesting. Okay. So, like, from a homeowner's perspective, I mean, the goal for, I think, pretty much everybody that we talk to, at least the clients that we work with, is longevity, right?
Hmm.
Obviously, we work and how we've decided to run our business is we look through the comfort, the operation, the reliability, the efficiency, and safety of the system. But when we're trying to come out and help the homeowner, really, we want to look through it from a lens of a couple different aspects. And it seems to me like looking through invoices and whatnot that longevity really seems to be on a lot of people's minds right now.
Hmm.
What's your reaction to that?
That makes sense. Everyone wants their equipment to last as long as possible. It's no one's ever prepared or rarely prepared to replace your HVAC system because it is a big expense for your home.
Mm.
When it finally does fail, you're kind of taken by surprise because I would imagine most people don't even think about their HVAC system in their home. It's just their house is hot and it's cool during the summer, so they don't pay any attention. But once it finally goes out, there's this big bill
Yeah,
happening. So obviously, yeah, absolutely, longevity is, I think, what most people want out of their system. And you get handfuls that are more concerned about just making sure they squeeze every dollar out of their utilities that they're using, or just the safety.
yeah, totally. And we operate in a couple different areas. So I know that we have a location down in St. George, Utah, which is a completely different climate and different
Hmm.
pieces of equipment than where we're located up here in Spanish Fork. And the way in which the equipment turns on and off, changes. So you talked about the cycle rates of about 2,500, cycles in a winter. How hard, or I guess how cold the winter is, how does that affect the cycles in your opinion? Like, If we have a mild winter, how should is it the same number of cycles? Is it different? Like, what's your opinion?
My opinion is that there's a lot of variables in HVAC. So if you have a really cold winter that stretches out into the shoulder season, so you're running your furnace more, you're going to stack up extra cycles on your equipment. It just depends on the temperatures, and it also depends on how warm you want your home.
Hmm.
If you want your home 78 degrees and it's really cold outside, it's got to run more and more just to maintain those higher temperatures when there's colder temperatures outside.
So that brings up a really interesting question. So I know we're putting on our technical hats here, which I love. Um, if somebody's wanting their home warmer, then I feel like their furnace would actually run longer, and so we'd have less cycles. Am I
hmm
thinking about that right?
Yeah, yeah, that's absolutely true. But you could have homes where the furnace is oversized.
Hmm,
It just blasts a bunch of heat through your vents, and your home's drafty, not good insulation. So it runs for a short amount of time, satisfies the thermostat, and it shuts down. But then the thermostat drops in temperature pretty quickly as well. So you can have the increased cycle rates, or you can just have really long run times.
got it. Okay, so with that, with the really long run times and the increased cycle rates, it sounds like design is a big part of that to begin with. But we can't really control a lot of that because of the fact that it was built inside the home. And I mean, we do a lot of new construction when it comes to custom home builds and commercial tenant improvements and whatnot. But in our day to day for our customers generally are people that have moved into a home, they have a Rambler, they're looking at replacing it, and they're wanting that system to last as long as possible. And so, with that in mind, kind of from that lens, uh, how can we, save our customers a little bit of money and give them an idea into what they can do to help extend the longevity of their system? I mean, obviously, they should have professional maintenance to let them know if it's oversized or
Mhm.
undersized or if it's correct. Same with insulation. Do you have the proper insulation? Do we have 1942 windows that are single paned? Did we update them? So I know that there's a lot of variables that play into it. So looking at it as though we're walking into just a normal one of our customers, how can we help them save money and keep this thing lasting as long as possible? What's inside of their control that they could affect?
I would say probably the number one thing is airflow. So that would be changing out your filters on a good regular basis, like a 1 inch filter, the ones you can get from the store. They're about an inch thick, change them out every month. Even
Got
if you
it.
pull it out and it doesn't look too dirty, change it out.
Got
It
it.
just airflow is really important for these systems, and as you reduce that airflow due to filters being getting dirty and slowing down, that furnace starts running hotter. It just puts more wear and tear on the system.
For sure. Okay. So maybe in layman's terms, like we talk about reducing an airflow. And a lot of times when I think about that and replacing the filter, I'm thinking, maybe I need a really inexpensive filter or something that doesn't have a lot of resistance. And
hmm
so I know that that's a strategy. What, in your opinion, is the right way to look at the filter?
Um, if I'm understanding correctly, so like if you just have a 1 inch filter, I would just get a good mid grade, one that's not too cheap, not too expensive, just there to protect the equipment and keep it from getting super dirty, pretty quick. That would be the biggest thing is looking at the filtration rating.
Okay. And I know that there's so many different ratings out there. Is it something that you have to be an HVAC professional in order to know these ratings, or how would we know like what rating to use if it's a mid grade? How would I tell if I was just looking at the filter?
So sometimes it'll be labeled as an FPR or MERV. We like to use around an 8 to 11 for the smaller size filters. That's going to be your good mid grade.
Got it. Got it. And with that, I mean, filter changes, that's awesome. Walk me through like what happens. What's the threat to the homeowner? What's the threat to the home if we don't regularly change them or if we don't have the right filter inside the system?
Okay. Well, there's going to be a lot of threats. So pretty much every component in that system it's threatened by the restricted airflow, whether it's overheating or more cycles, things are running harder. they're running more, they're clicking on and off more. Um, Pretty much everything in that system is going to be a threat. The biggest thing, I mean, you're going to have your heat exchangers. That's what contains the natural gas that's burning through your equipment, and that vents outside. That's how we're heating that home. The air from your blower that moves the air through your vents, that blows air around those heat exchangers to grab that heat and blow it in the home. Those heat exchangers get extremely stressed out and they can start failing, leaving potential for, flue gases to enter the home. Another component, right off the bat, is the blower motor. That's the component that moves the air. If that is, say you put a piece of cardboard where your filter goes, that blower motor is going to start screaming, trying to get air from somewhere because it is sucking air through returns
Hmm.
and blows that air through the small supply grills. So if it can't move the air that it's designed for, it's just going to give it up the ghost basically.
Got it. Well, I put you strategically in a nice place over here. Do you mind handing me that sign here? Because I think it might be fun to walk through a little bit about some of like the different parts that are on it. And you can totally just look towards it and whatnot. But where is the blower like on most furnaces?
The blower motors on most furnaces are going to be down in this lower compartment. That's where that blower sits.
Down in the bottom where the
Yep,
sticker is?
down in
Got
here.
it. And then where are these heat exchangers that you're talking about?
The heat exchangers are behind this whole back plate here. So you see up here, you got burners. Each one of these burners, flames are shooting out of those, and they go down each cell, and that gas is traveling behind this plate through a series of tubes until it hits this component here, which is called an inducer motor, and then that helps vent it outside, that gas.
Got it. And then the filter is normally where in the system?
Usually the filter, I mean, there's a lot of different places. So you can have them in filter grills up in the ceiling. Um, I'd say most commonly is next to the furnace. So this is our filter here. Um, that's either it's on the side of the furnace or underneath it. There's going to be a little cabinet where you can open up the filter and change it, or in filter grills
Got it.
in the ceiling.
Okay. And so thankfully, since, heating season is almost over, we probably don't have to worry about filters anymore
Well, I wish, but
then.
so when you're running your furnace, you are moving the blower, or yes, using the blower to move air through these heat exchangers and blow that heat through the home. When heat's not running, we're not using this equipment up here, but we still need the blower to move air through the ductwork for your AC.
Hmm.
And that component for the AC is up here.
Got it.
So air still has to pass through there.
Okay. So the air does have to be all year round, which is, makes sense, obviously. However, if the filter gets super dirty or if the filter is non-existent, is that really a problem for the furnace or the AC?
Absolutely. It's a huge problem. That's going to be the quickest way to replace your equipment as fast as possible.
Why is that?
So, take for example, you don't ever put filters in. The blower motors, or the blower will, and the blower motor is going to get dirty, which causes it to reduce how much air it's moving through the system, and also just hurts the motor itself because it's trying to move the air, but it can't. And then also on this evaporator coil up here, that becomes your filter now. So we block that up. You're not going to have any cooling.
Got it. Okay, so it's kind of a multi thing where if the filter is not regularly replaced, not only do we have damage that can happen in the heating season, but then there could be damage that we all of a sudden discover in the cooling season as well.
Absolutely.
Okay, got it. So for all of our friends and everybody in the chat, one of the things that pops up pretty regularly is if we get dirt and debris throughout the system, then duct cleaning is something that we see a lot of people pushing. How would that help the system, or does it help, or what would be the recommended action that a homeowner could take?
If your system's extremely dirty, a duct cleaning is just going to give you peace of mind that your ducts are clean, but the system internally, the components are still plugged up.
Hmm.
They're still working overtime to try and do their job.
Got it.
So duct cleaning is best when you're using it hand in hand with an upgraded filter to filter more air, pull more particulates out of the air, maybe some ultraviolet system set up just to make sure the overall system's clean. I feel duct cleaning is just more of a indoor air quality concern, but it doesn't really affect your system.
Okay. Yeah, I heard it once kind of explained like the duct work is like the arteries and the veins inside the system. So you may have like plaque or something that's built up inside of these arteries and veins, and the duct cleaning will clear it out. But your circulation, like what's pumping all the blood, or in this case all the air, and pulling it, is going to be through the blower motor. So that's if we can clean all the air before it gets into that blower motor, and then it pushes out into the system, the chances of your ducts getting super dirty exterior to right next to where the registers are, it's probably a lower concern. You probably aren't going to build up as fast. And I've heard some stats from like the American Lung Association and other government entities that it's recommended to potentially do duct cleaning maybe once every 2 to 7 years, just depending, because there is some dust particles that get through, and we don't want to take old dust mite particulate in particular and keep blowing it. But the filter would really be the first line of defense then. Is that right?
Absolutely. Especially if you have a 1 inch thick filter, look at upgrading to, say, like an April Air. As this filter itself, when that blower kicks on, that filter seals and it doesn't really allow any air past it, and it keeps everything super spotless and helps keep the ducts from getting dirty.
Hmm. Okay, so one of the comments that we had previously is that the 5 inch filters are so much more expensive, or the upgraded filters are so much more expensive than the 1 inches, and so if that's the case, it kind of feels sometimes like indoor air is hard to measure. It's hard to quantify on what it's protecting or what it's not. Why would like an upgraded system help just beyond like particulate? Why would somebody want to invest into a larger filter if, you know, it's kind of hard to measure? If you're up on your 1 inch filters, it should be fine, right?
Um, well, you'd hope so, but no. As for the 1 inch filters, you take a brand new 1 inch filter and you stick that in your system. It's naturally restrictive. Just excuse me.
You're good.
It's naturally restrictive because there's not enough surface area on that filter itself, so the air kind of gets clogged there, even brand new. So you put it's a common thing during the winter as well. People go to Costco and they get their big allergen 1 inch filters. They throw it in the system, and almost instantly the furnace starts overheating and shutting down, and
Mm.
it turns into a breakdown just due to a brand new filter. There's too much media and not enough surface area for that media to really do its job. So we're just back up too much air.
Got it. Okay. So I guess when you're saying too much media, don't the bigger filters have more media than the 1 inch filter does?
Well, it depends on the MERV rating. The higher the MERV rating, the more media is in there to help filter out the finer particulates. But the bigger media or filters, the media, you'll see pleats on them. They look like big cones. The deeper those are and the wider those are spread out, the easier it is for air to pass through.
Mm, got it. Okay. So when we have if we have easy air passing through, that's going to help make sure that we're getting and delivering the right amount of air through the furnace and through the AC. And then if we have a 1 inch filter, it's going to get caught with, potentially more particulate, maybe not, but it could restrict the airflow just in nature where it doesn't have the deep enough pleats in order to reduce that pressure through the filter. Is that right?
Absolutely.
Okay.
Yep.
And then in tandem, like let's say, just for argument's sake, you know, we've got a filtration system that like this one that might need to be put onto the system, and it's being recommended. And I'm just going to throw out a number. Let's just say it's, $1,000 in order to do this type of filter upgrade.
Mhm.
I mean, $1,000 is going to get me a heck of a lot of 1 inch filters. So, what else am I getting other than potentially, maybe some static pressure, drop? In theory, if I have $1,000 and I buy a lifetime's worth of filters and I replace it like once a month to maybe even once every 3 weeks, what else am I harming in the system by sticking with that 1 inch filter? What would the cost be to me as a homeowner that I'm not seeing, that a bigger or better $1,000 filtration system would save me in the long run or prevent for me in the system.
Okay. With 1-inch filters, if you're changing them out, say every month, which let's be honest, most people do not.
Sure.
I don't even I forget about my filter in my system all the time. But putting 1-inch filters in that little cabinet, we are still going to get air that's going to pass through the filter on that, or just pass around the filter and still go through the system. 1-inch filters, they're cabinets, they're almost none of them are perfect. You can't get such a tight fit that air has to go through the filter. It's always going to find a way around it. So, getting a lifetime supply of 1-inch filters, you're changing it out, you're basically reducing how soon you're going to have to spend money to clean components, because we are still going to have air passing through it. But also, as going back to my previous statement, the 1-inch filters are just restrictive naturally brand new, just due to how small they are. You're going to end up paying money, say $1,000 in cleanings at one point in time. Maybe it's 5 years down the road or sooner. And then you're also going to be dealing with the increased wear and tear and how hard that equipment's running.
Got it. Okay. So the whole concept behind the filters isn't just like, hey, you're going to have better clean air to breathe. That's a byproduct of the filter. But the strategy behind it is if we invest up front in a filter that's going to capture more particulate, that should reduce the number of cleanings that you need on the blower, on the heat exchanger, on the evaporator coil, and ultimately will just keep the efficiency of that equipment more like how it was supposed to be from install, that you do get, healthier air for free. But the strategy for the recommendation is to make sure that we're protecting these components from potentially breaking down and maintaining the efficiency. Is that fair?
Uh-huh. Correct.
Okay.
Yep.
Got it.
Yeah. I have actually been out to systems with these April airs because they do seal with how they are designed. I have been out to systems that are 20 years old and they looked brand new.
Totally. Yeah. And that's the goal, right? I think there's a lot of uh, talk around when people should replace furnaces and when they shouldn't. Same with ACs. I've I've see with different comments that their old R22 system, it was the best cooling system that they had. They never had problems. Same with old furnaces, and then we get brand new furnace installs, and there's all these problems, and things fail more frequently. Why do you think that is? Like, why is it that that seems to be the running narrative almost across the United States?
I think a big part of it is there's so many restrictions now on efficiency standards and trying to make this equipment just squeeze every penny out of every dollar. So these manufacturers are putting in a lot of technology to meet those standards, and I feel that extra technology starts leading you down that path. There's more to go wrong
Hmm. Got it.
versus the old school style equipment that's super basic. It was bulletproof, wasn't really efficient. It did cool your home, but it just it just ran.
Sure. What are some of the, in your opinion, what are some of like the building code changes or different reasons why these restrictions were put out? Like, are these just a play for from DuPont or from somewhere that is like trying to gain more money, or is there like an actual reason why like more safeties or more parts or different efficiencies and things like that were put into like residential homes specifically?
Um, well, for example, like the refrigerant itself, we got a new refrigerant out right now, as you're aware, the 454B and R32. The reason why they keep coming out with them is because they design new refrigerant that has a lower global warming potential. That way, because any AC and coil, evaporator coil, it's going to start leaking at some point in time. So we're going to start losing refrigerant into the atmosphere. So that's one big reason with the refrigerant. They redesign it. They're trying to get more, um,
It's environmentally friendly,
yeah,
I guess. Yeah.
more of that out of the refrigerant. So when they do leak, it's not as harmful as the older refrigerant to the atmosphere. But as for everything else on the furnace, I mean, I don't really have an answer on why. I know with the blower motors, I think it was around 2020. The older blower motors, they're called PSC. They had capacitors. They used a lot of energy to run. But if correct me if I'm wrong, but I believe it was around 2020.
Hmm.
It was standard that all equipment was going to have a sort of a variable or ECM motor, and it's just really cheap and efficient to run, like pennies on the dollar, which helps the infrastructure stay more intact, less utilities for the homeowners,
Hmm.
just all around. More environmentally friendly.
Yeah, that makes sense. I heard one of the builders and whatnot talking a little bit about how the tightness of the homes have like even from 1990s like up into you know early 2000s, and then again like as different building codes change, the tightness of the home doesn't allow as much fresh air to come into it. And what I found was fascinating is like we think about efficiency, and so we're like, let's make everything as tight as humanly possible. And then what ends up happening is if we have less oxygen that's flowing into the home, or, let's say we don't have as much combustion air, which sometimes people cap off because of that cold draft that's coming through. And don't do that. Don't do
No.
that, please. And the reason is because that our flame, it really needs to use oxygen in order to burn, right? And so what was described to me is that when we don't have enough oxygen and we have a really tight home, even us breathing in oxygen and exhaling carbon dioxide, the carbon dioxide count goes up inside of the home.
Mhm.
And then that can be different air that the appliances are using in order to burn. And so, if for whatever reason there's a failure, what happens is the flame is still going to try to burn. It's just going to steal oxygen from carbon dioxide and create a much higher count of carbon dioxide inside the home. And so, like, if you had a 1942 home with an old furnace that had a, failed heat exchanger, and even if it was potentially pumping carbon monoxide into the atmosphere or into the home, because of the amount of fresh air that was literally blowing through the walls, people want to get carbon monoxide poisoning because it physically like was getting offset by the amount of oxygen that was inside the home. And now with it being so tight, that doesn't happen. And so a factory was talking about how a lot of the safeties and things that they're putting in that cause it to fail, it wasn't that it's so much failing regularly. It's that one, was it installed correctly? Because we're at a higher efficiency, so we don't need as big of a furnace anymore. Whereas, back previously in the 90s, it was like, how do we get these registers toaster hot? And how do we get as much heat into the home because our efficiency wasn't quite there? And so I wonder if what we're seeing is a balance of maybe older homes that have been upgraded. So now they're more insulated. And then if we have a contractor or somebody that comes in and replaces this larger furnace that was designed for a home that had tons of airflow that was just coming through these windows, the heat load that we would need to heat the home so much higher. And now that it's tighter and more efficient, we actually need a smaller furnace in order to maintain the same temperature. And we're also not running at like hundreds and hundreds and hundreds of degrees. Our limit that's inside the furnace is limiting the amount of heat that's being produced because of the thinner metals and trying to maintain with the energy efficiency. Which I guess, and to be fair, if everything is perfect, makes a ton of sense. Like if we're specking out a home, if you and I were building a home, we could spec it out so that you need the smallest size furnace and it's going to run the least amount of time. And those thin heat exchangers and those different components, they probably could last 20 years. But because sometimes we just shove them and paste them into these homes when we replace them, we cause immediate issues because we have the wrong size equipment for a home that was built with a different heat load value. Maybe the contractor didn't do a heat load calculation on the home at all, and also, what we're forgetting is the duct sizing, right?
Yep.
And that causes a whole nother amount of issues. So, I guess what's your response to that? That's kind of a thought that I've heard in the past.
My thought on that is I agree with everything you're saying there. Yeah, there's a lot to unpack with that. Um, but you hit it nail on the head
Mm.
with all
Sometimes I nerd out a
that.
little bit on
No, I
this.
love that.
Yeah.
Yeah, no, that was great information because it's all just it's so true.
And I think too, like, for people that are listening and whatnot, I I I feel like there is a problem specifically in Utah and probably Colorado and any other state that doesn't have a lot of regulation around who can be HVAC, you know, uh, technicians or even
Hmm.
owners or whatnot. It seems like we have an epidemic of people that will come in and they'll say, "Hey, we have this furnace that's from 1990 and it was 135,000 BTUs, which is just a big furnace, and maybe it's on a 1200 square foot above grade house." And then they replace it with a similar size. It seems like we have an epidemic of missized equipment. What's been your experience in the field around here in Utah with that?
It's very common. Most new builds are just done not properly with the equipment. Like they'll take so you get your gas valve here, and then they'll go through because the homeowner wants zoning in their home. They want thermostats everywhere so they can control different areas as needed. But they'll throw in a big 100,000 BTU furnace, and then they do a single stage valve. What that means is you're burn whatever you derate it to. That's how many BTUs you're running. Say it's 80,000 BTUs. We can't throttle this down anymore. So if we have a 4,000 square foot home and we have a zone that's say 300 square feet just calling, now we're trying to move all that air into one zone and it just can't get there. It starts busting dampers because the pressure gets just too heavy. And ultimately, it just destroys a furnace within a couple of years because it is designed to move that amount of air all the time
Yeah,
to
totally.
run safely, efficiently, and comfortably for the home.
Yeah.
Slow wins the race, not dumping a bunch of heat out. So I would say it's more common than not that things are not sized correctly. It's just not done properly.
Yeah, that's interesting. I was at Johnstone a couple of years back. The Johnstone is a pretty large national distributor for HVAC equipment and plumbing equipment. But as you know, uh, helping chat here. I know it looks like they know, so that's cool. Don't yell at me, chat. We're good. But regardless, it was a really interesting thing. I can't remember the name of the gentleman that was running the class, but he had broken down. This was in Colorado, which is similar to where we're at here. It's going to be in the same section of the United States. We're not southern, we're not northern, so we're kind of in the perfect area for not having super cold winters and super hot summers. And since we don't have a lot of humidity, that's really what drives the AC efficiency. So we're in the sweet spot when it comes to HVAC in all reality. And he was describing what he calls bin hours. So it's if we took all of the temperatures that we would experience in the winter, what is the hours in which a furnace would run based on temperature? So he used an example, and I'll see if I don't have it prepped here, but I'll see if I can share it later. But it showed on average in a winter in Colorado, out of the entire time that a furnace would operate, from maybe -10 degrees all the way up to 65 degrees. That's when a furnace may kick on. About 95% of all of the time that your furnace is running is actually above freezing.
Mhm.
It's above 32 degrees all the way to about 50 degrees, I think it was. I'll have to fact check myself. But that means that when I'm designing my furnace, though, I still have to have the furnace heat whenever it's -10 because I could get down there. So if I don't size my furnace for when the worst case scenario happens, then we can freeze pipes, we can have issues, your furnace never shuts down, all of the temperature inside your home just consistently drops while the furnace is running. But the majority of our winter, like I think our average temperature here is like 40 some degrees, right?
Yeah.
So we have all these furnaces that are designed to only run at one stage is what I'll call it, or one gear. It has, like in this example that you were saying, let's say this is a 80,000 BTU furnace,
Mhm.
it has to put out 80,000 BTUs. Well, I may only need 80,000 BTUs when it is 32 degrees or lower. And so any other time that my furnace is heating, it's actually running as though it's oversized. So how do we solve that for like our homeowners?
Um, well, getting someone out there to look at your equipment, especially a technician, first off, to see how well it's operating, look at the general sizing, but ultimately, just getting into the variable equipment. It is more expensive, but it's just extremely efficient, and it just keeps your home comfortable year round. May seem like it's running longer, but what it's doing is it's really throttling down. So it's not really spending that much on utilities, but it is giving that constant comfort throughout your home.
And that'll definitely reduce the number of cycles
Yep.
too, right? And
Yep.
so if we have ton of wear and tear that happens on startup, I had it described to me that um, when an electric component starts up, it's like these lights that we have. If we were to sit here and just flick these lights on and off, 5,200 times, the chances of that bulb failing are pretty gosh darn
Yeah.
high versus just keeping it on and maybe, dimming the lights a little bit when we don't need as much light, and then being able to throttle up and increase when we need more. That would extend the life of those light bulbs, and that's kind of the idea between staged equipment and HVAC. Is that right?
Correct.
Okay.
Yep.
So let's say that we have, we're trying to extend the life for our clients. And so it's good to know what technology is out there. So if and when they come to a position of needing to replace their equipment, getting something that can stage itself in a way that, matches our environment rather than a single stage is probably really good. But if we got a homeowner that's just stuck with maybe like, you know, 10-year-old, 12-year-old single stage furnace that, is oversized and they're trying to squeeze the most life out of it, what can they do or what would we recommend to do like professionally in order to squeeze the most life out of that furnace right now?
Okay. Well, best thing, obviously you're having a technician out. They're going through the entire system. They're looking at every possible threat to the system to ruin that longevity. So if things need to be cleaned, keeping them cleaned, upgrading the filter to get more air moving through there also may turn into adjusting the gas pressure, reducing it for altitude. So it's burning efficiently and cleanly, and we're not overheating. It's really kind of throttles it down. Every piece of equipment should be derated here in Utah when it's installed. Just going through all of that and making sure everything's just set up correctly, clean, and operating safely and properly.
Got it. So from a homeowner perspective, like kind of understanding what type of equipment you have can kind of help make some of the decisions that they could do. What are like obviously replacing the filter regularly or, potentially adding on a filter, cleaning the different components and whatnot to make sure the system is going to last as long as possible. Is there any other item or anything else that the homeowner could do um, to help with the longevity? Like, is there any hack or tip or anything that we could, give them to say, hey, if you do this, you might squeeze a little bit more life out of it?
Number one thing is just don't reuse your equipment at all. That's gonna
I love it.
that's gonna make it last for a very long time. Or just setting your temperatures down really low. But to squeeze maintenance plans help squeeze that every little bit of life out of the system. And then also depending on how it's installed, what type of equipment it is, there's certain accessories out there to help protect it and last as long as possible.
Got it. Um, the last question that I have, and this is a can of worms. I know it's a hot topic, and anytime I get in any chats or Reddits or anything like that, this is the number one thing that people complain about, or they just go off about companies, and that is failed heat exchangers.
Mhm.
I cannot tell you how many times I have read a comment about a company has come out, said that there's a failure in the heat exchanger, they said that they need to replace it, and then the homeowner gets a second or third opinion, and the other companies are not finding the failures in the heat exchanger. There's no carbon monoxide inside of the home. And so they're just kind of like stuck in this quandary of like, who's right, who's wrong. And to be fair, like, we don't anybody can really start an HVAC. So to be fair, it's possible that, some people don't know what they're talking about. And to be really fair, we are a business after all. And
Mhm.
so a business is there to generally take care of the people that are in their company by making money.
Yep.
So, and depending on how they incentivize their technicians, you can, if a technician is just fully incentivized by commission, we can totally see how somebody may stretch, maybe not stretch, or maybe they just don't know the whole answer, but they could, strongly recommend replacement.
Yeah.
So, if we have a homeowner that, as maybe is in this situation, or they have a piece of equipment, it's been running fine, haven't really had much maintenance on it. They call out a technician. First time they have maintenance, the technician's telling them that they have to replace it, and the homeowner doesn't want to. What are some tools or some devices or some things that they could buy on like Amazon or somewhere where they could, purchase it to either try to test the furnace themselves or to protect their family, because it's a really hard time. Obviously, I would say try to work with a reputable company and
Hmm.
figure out who would answer that question best. But in the age of, AI and the age of Amazon, I mean, there has to be something that maybe a homeowner could purchase or something that they could do to figure out if what the technician is saying is real. What's your opinion there?
Um, yeah, that is a can of worms. But so going back to things that they could buy to help protect themselves and their family, obviously every home needs carbon monoxide detectors. But unfortunately, if a heat exchanger fails, it doesn't automatically mean it starts leaking carbon monoxide into the home. If for whatever reason it gets to that point where it does start leaking, I would feel like you're more likely to start dealing with a low level CO poisoning problem versus all of a sudden there's 400 parts per million and all your CO detectors go off.
Mm,
So good CO detectors is a good first line of defense. Ones that go off at a lower level, like the ones that we stock that go off at 70
mm.
parts per million. Um, just be wary of that. But to absolutely make sure that it's never leaking, you'd have to pay a technician to camp out at your home 24/7 with a combustion analyzer that can read all the way down to 1 part per million to make sure nothing is starts leaking at all.
So I know we got a whole bunch of do it yourselfers and whatnot, which I love here. So combustion analyzers, like if a customer purchased a combustion analyzer, because now you can get all these different tools in different places. Um, Walk me through how they might use that in order to kind of figure out and prove if something's happening.
How they would use that if they did spend the money to get a combustion analyzer is definitely get some education on it and how it works, what you're seeing, because there's going to be a lot of readings on there. And if you don't know what they mean, it give you some false alarms there. But I mean, the basic thing on most combustion analyzers, they're going to have a CO
Hmm.
level, which is your carbon monoxide, and that's what we put in the ductwork when we're checking furnaces, and we just run it there for as long as possible when we're finishing up to make sure it doesn't increase at all.
Yeah.
That's the biggest thing you're going to be checking. There'd be really no point to start getting into analyzing your flue gas unless you really wanted to go down that road, but definitely you need some education on it and what all the numbers mean.
Well, that's a good call out too, because it's possible that a furnace could have a failed heat exchanger and could be leaking some sort of combustible gases inside the home, but we're burning so cleanly that we really don't have a high level of carbon monoxide at that moment.
Mm-hmm.
So I remember there was a call that I was reading about where a customer had like 35 parts per million inside of the ductwork. The technician came in, they hooked up the combustion analyzer into the ductwork. Like, yeah, you got 35 parts per million, and condemned the furnace, and basically went through and said you have to replace it. They didn't like how the technician was doing that. He was very forceful, and then all of a sudden another company came out, and come to find out the carbon monoxide was coming from their home. It
Mm-hmm.
wasn't coming from the furnace. So walk me through how that's possible.
How it's possible to have CO in your home not coming from your furnace?
Yeah.
Well, for example, I think it was 2 years ago, just south of here. I went out to a home. It was the fire department was out because they found 30 parts per million in the home and they shut down the furnace. Come to find out that the furnace heat exchanger was failed, but it wasn't the what was causing it. After going through, because we take the blinders off, we look at everything. There's a lot of reasons why you can get CO in the home, whether you start your car in the garage and it's infiltrating from the garage itself into the home. You have a gas burning stove.
Hmm.
And let's be honest, here in Utah, most microwaves, they aren't vented outside. It just blows the air, the exhaust back into the home. So,
Yeah, and ovens. Yeah.
yep. So most people, when they're doing canning all day or whatever, you start building up a level seal in the home. Fireplaces, another example, water heaters. For specifically this call, what happened is the combustion air intake is the lady did feel the cold air coming into the mechanical room. The fresh air for the water heater and the furnace flames to light, to consume. She spray foamed it. So we had no fresh air coming into the home at all. And what started happening is it's basically the water heater, it will draft out of the venting and go outside. And if you look on top of the water heater, they have that natural draft hood so air can go in with it and help it draft out. Since we started burning all the oxygen out in that space, it was a closed mechanical room, the flue gas started spilling on top of the water heater, getting into the mechanical room, and there was open return joints. So the furnace, when it was running, it was sucking in that gas and
Hmm.
distributing it throughout the home.
Interesting. Yeah. I think the goal here is like to try to be as transparent as possible, and I think that's what you're saying. Take the blinders off.
Mhm.
We've got to look at it all. Like, a failed heat exchanger. Of course, the American Gas Association, who regulates all gas appliances, states that if there's a visual failure or hole or defect in the heat exchanger, they require either the replacement of the heat exchanger or the replacement of the furnace. And from a contractor standpoint, that puts us in an interesting position because if the American Gas Association is saying we should do this and the factory is also saying they need to replace it and a homeowner doesn't want to, it's hard to work on that appliance because somebody has to take on the liability at the end of the day.
Yep.
And unfortunately, normally it falls on the contractor. And so I totally understand and recognize that sometimes it's an unfair position to be.
Mhm.
But I also have to recognize that, there's a lot of bad processes. And, unfortunately, sure, there's probably some bad apples out there, but it's possible that, technicians in general don't have enough training in order to see. And what I love about this conversation and why I love, chat and everybody, weighing in is the fact that if we can give some education to our customers about like what it is that we're doing and why it's important, then I feel like they're going to be able to make the best choice for their home.
Yep.
And I know you personally, like you have a heart for educating people and wanting to make sure that all of your guys educate people in the right way too. Um, I guess to close out, that would probably be the number one thing is that it's going to be impossible for us to come in and just give a perfect exam or a perfect way in which to make any system last as long as possible because there isn't just a one size fits all solution. But there are tools out there that people can purchase if they do want to do some testing on their own. And there are companies out there that want to be open with the information and talk through it. And I know that's what, we're trying to do and
Yep.
what you've really focused on with your technicians. So if you had something in closing just to encourage all the homeowners and maybe other HVAC technicians out here and anybody else that's listening or watching this, what would that be?
Um, One of the most favorite things I've loved that I have learned and from Triple T is the fact, especially with heat exchangers, it is a delicate process. You're out. It's almost Christmas time. People want you out to make sure their furnace is safe. It's been operating properly. And let's be real, a failed heat exchanger doesn't mean the furnace stops working. It can keep going and going. We come out there and ruin their holidays because we go up and show them a picture or a video of a failed heat exchanger. And now they're looking at expensive heat exchanger repairs, and usually it's better just to replace a furnace at that point. But what I absolutely love is when we are going through the heat exchanger, we check the most common areas that they're known to fail. Say, particular me, if I'm not finding that issue on the common areas, I still scope the entire heat exchanger. Is what I teach everyone else is just look at everything. And um, once we go through, and say if we find a crack is a crack. Regardless, there's always potential for it to open up and get worse. but we have to be 120% sure that it is a crack. We're not going to show you a blurry photo. We're not going to show you something that anyone on the internet could look at and be like, I don't know. I want my pictures or my videos that I send you and show you. Anyone in the world looks at it and like, okay, yeah, that's a crack. So we like to take a video of the failure. We show the model and serial of the furnace. We're not pulling the wool over your eyes. We like to be as transparent as possible and let you know, hey, this video came from your system, and educate. And if we come across something that, in our experience, looks like it could be a crack, but it's just too hard to say 100%, yes, it needs to be tagged off, we put it in the customer's hands. We give them a good education about the potentials, how the furnace works, and what can happen if it's left unchecked. And we put that in their hands and let them decide what they want to do with it.
Totally.
I love that.
Yeah, I do too. I think that's key is it's their home at the end of the day, and we're here to facilitate the education and just be the experts to uh, be experts in education. Don't be experts in dictating what the customer should do inside of their own home. And I think that's a really interesting distinction. And I'd encourage everybody to really double down on the education in the space of HVAC, since it's something that we take so for granted for, and arguably has extended life of mankind because of having temperate temperatures instead of being wild fluctuations. And education is key. And so I guess that's a really good way of wrapping this up, is that we want to be facilitators of your education, and we'd love to know from chat, from everybody else, is there anything that you guys are going to have questions on coming into this next season? We've got our AC season that's coming up. It's going to start off. AC is a whole nother conversation, all about thermodynamics, latent heat, sensible heat, glide ratios. It's insane. I love it. But at the end of the day, we want to make sure that it's palatable for everybody. So chat, let us know. We really appreciate you guys taking this time. Mac, thank you so much for bringing your wisdom and knowledge. And I know that you're a advocate for always learning yourself, and I love how you champion that. So let's all keep learning, and who knows, we might learn something as well from the comments, and then have to come back and be like, we learned. Let's change something. So love that so much. Thank you guys. I really appreciate it. This has been Locali Podcast. We'll catch you next time. Triple T, heating, cooling, plumbing, electrical in Utah County, all the way up to Salt Lake and all the way down to St. George. We'll see you guys later.